Good day, my name is Maged Kamel and I am a civil engineer. We will continue the discussion of the LU factorization, but this time the discussion will be for the 3x3 matrix. First, I will refer to one of the math sites, which is Helm, HELM. This is the abbreviation of Helping Engineers Learn Mathematics. The reference has useful data which can be downloaded. In this video, I code the content as follows. Start with the first question. Do all matrices have an LU decomposition? The answer is sometimes it is not possible to write a matrix in the form of a lower triangular multiplied by the upper triangular. Why not? An invertible matrix has an LU decomposition provided that all the leading submatrices have non-zero determinants. We will move to the second slide to apply this statement. It is required to find LU decomposition for a given 3x3 matrix. The matrix first row is 3, 1, 6. The second row is given as -6, 0, -16, and the third row is 0, 8, -17. We check the submatrices determinants to be non-zeros as follows. The first submatrix is A1, which is the corner element of the matrix, simply A sub 1, 1. It has a value of 3, which is not zero value. The second submatrix is A2, which is a matrix of 2 by 2. Elements are 3, 1, -6, and 0. The determinant value is not 0, it equals +6. Finally, the entire matrix, which is called A3, its determinant is -6, not 0. Since all these submatrices have fulfilled the requirement, then the given matrix can have LU decomposition. We will proceed to estimate the lower and upper matrices for the given 3x3 matrix. For the lower matrix L, by definition, we have L sub 1, 1 equal to L sub 2, 2 equal to L sub 3, 3 equal to 1. Then it is required to find the values of L sub 2, 1 and L sub 3, 1. L sub 2, 1 equal to A sub 2, 1 divided by A 1, 1, while L sub 3, 1 equal to A 3, 1 divided by A sub 1, 1. Consider A sub 1, 1 as a variable. We can see the two arrows going from -6 to 3. Divide -6 over 3, this would give -2 for L to 1, and the second arrow goes from 0 to 3, then L31 will be equal to 0 divided by 3 equal to 0. The next step is to apply Gauss elimination to get the upper matrix U1. Multiply the value of L sub 2, 1 by -1 by R1 and add it to the second row. Multiply the value of L sub 3, 1 by -1 by R1 and add it to the third row. We can see the matrix U1 as a 3x3 matrix that has the first row of 3, 1, 16, which is identical to the first row of the original matrix. The second row is 0 to -4, while the third row is 0, 8, -17. The next step is to find L sub 3, 2, which is the last unknown for the lower matrix L. From the previous slide, we have U1. Consider A sub 2, 2 as a pivot. divide A sub 32 over A sub 22 to get the value of L sub 32. Check the arrow which goes from 8 to 2. The division of 8 by 2 is equal to 4, which is the value of L sub 32. Now we have completed the elements of the lower matrix. These elements are 1, 0, 0, minus 2, 1, 0, 0, 4, 1. We proceed to find the final upper matrix. Multiply minus L sub 32 by R2 and add to R3. Then we multiply minus 4 to the second row of the U1 matrix and add the value to the third row. The final upper matrix is 3, 1, 6, 0, 2, 4, 0, 0, minus 1. Now we would like to check the expression of L multiplied by U equals A. We will perform the row column operations of the multiplication of the lower matrix L by the upper matrix U. We multiply row 1 by column 1. So we multiply 1, 0, 0 by 3, 0, 0. This will give the value of 3. This 3 is the value of A sub 1, 1. We multiply row 1 by column 2. Row 1 is 1, 0, 0 by column 2, which is 1, 2, 0, will give us the value of 1, which is the value of A sub 1, 2. We multiply row 1 by column 3. Row 1 is 1, 0, 0. We multiply by 6 minus 4 minus 1 will give us the value of plus 6, which is A sub 1, 3. We multiply row 2 by column 1. Row 2 is minus 2, 1, 0 by 3, 0, 0 will give us the value of minus 6. This is the value of A sub 2, 1. We multiply row 2 by column 2. Row 2 is minus 2, 1, 0 by 1, 2, 0 will give the value of 0, which is A sub 2, 2. We multiply row 2 by column 3. Row 2 is minus 2, 1, 0 by 6 minus 4 minus 1 will give us the value of minus 16, which is the value of A sub 2, 3. We multiply row 3 by column 1. Row 3 is 0, 4, 1 by 3, 0, 0 will give us the value of 0. This is the value of A sub 3, 1. We multiply row 3 by column 2. Row 3 is 0, 4, 1 by 1, 2, 0 will give us the value of 8, which is the value of A sub 3, 2. Finally, we multiply row 3 by column 3. Row 3 is 0, 4, 1 by 6 minus 4 minus 1. This will give us the value of minus 17, which is the value of the element A sub 3, 3. Thanks a lot. We will continue next time to solve for the three unknowns by using the LU decomposition. Goodbye.